Russia has successfully completed the testing of an impossible missile that the West didn't believe existed, but that's not what they were afraid of. And let's break down exactly what it was that they were afraid of. Testing of the rocket, which the world thought impossible, has been successfully completed. Vladimir Putin said this during a speech at the Valdai International Discussion Forum on October 5, 2023. This is a Burevestnik cruise missile with a nuclear propulsion system on board, allowing it to have an unlimited range at the lowest possible altitude, circling the terrain. The very concept of a nuclear cruise missile is far from new. Such missiles have been in development since the mid-1950s. For example, the U.S. project, SLEM, a low-altitude supersonic missile that is a nuclear-powered unmanned direct-flow jet engine capable of delivering thermonuclear warheads deep into enemy territory. Two working prototypes of the direct-flow nuclear engine, Tory-II and Tory-II-C, were developed, manufactured and successfully tested as part of the SLEM project. The SLEM concept is a 27-meter rocket with a mass of 27.5 tons, capable of reaching a speed of Mach 3.5 and flying up to 180,000 kilometers. However, after 7 years of active development, the project was closed without testing a single sample. One of the reasons for the project's closure was the heavy radioactive contamination of the area due to the operation of the nuclear engine. The radioactive exhaust was so strong that the U.S. couldn't even find her a place to test it. The reactor was cooled directly by blowing air through the reactor core. The air heated to 1200 degrees Celsius burst out of the nozzle in a jet, pushing the rocket forward and taking with it all the products of radioactive decay. The direct-flow nuclear rocket engine could only operate at high speeds of Mach 3 to 4, while heating up to 1200 degrees Celsius. The rocket was accelerated to the required speed by rocket boosters, and then the nuclear direct-flow rocket engine took over. There were no materials that could withstand such high temperatures and neutron irradiation at that time, and there are none to this day. Therefore, core cooling requirements were stringent. In the 1960s, the Soviet Union and the United States were actively working on the development of nuclear-powered aircraft, whose reactor core should heat the air, thus replacing fuel combustion. In theory, such flying machines could stay in the air for weeks. For example, Lockheed's CL-1201 nuclear-powered giant transport plane project, which could act as an airborne aircraft carrier, had to be in flight for 41 days. Here are the dimensions of the Lockheed CL-1201 compared to the Boeing 747. Back then in the 1960s, the prospects for nuclear energy seemed endless. But if such flying machines can be created, why did many experts consider Burevestnik an impossible rocket? The fact is that the Burevestnik is too small a rocket to mount a full-fledged nuclear reactor on it. Its length in flight is about 9 meters. For comparison, the Tomahawk cruise missile is 5 meters 84 centimeters long and has a range of 2,500 kilometers, while the KH-101 cruise missile is 7 meters 45 centimeters long and has a range of 5,500 kilometers. That is, the dimensions of the Burevestnik practically correspond to the dimensions of a conventional long-range cruise missile. And according to modern ideas, it is unlikely to create such a compact and at the same time powerful nuclear reactor. Yes, indeed, the reactor should be very miniaturized, but at the same time very powerful per unit of its own mass. For comparison, here's a man in the background of the SLAM project's nuclear engine. This is Tory-II-C, photo before testing in 1964. And this is what the layout of the Burevestnik nuclear engine should look like. A nuclear reactor is a nuclear reactor, and it is estimated that the useful engine power should be between 700 and 1000 kilowatts. Consequently, the thermal capacity of the reactor must be much larger. Burevestnik is a subsonic missile, and this makes it very difficult to cool the nuclear reactor. Illinois Technological University physics professor Jeff Terry, citing the engine power of the Tomahawk missile, determined the useful power of the Storm Petrel's engine to be 766 kilowatts. The only known way to build such miniaturized but powerful reactors is to use a fast neutron reactor. It is the only type of reactor that fits the criteria of power and compactness. Russia is quite capable of creating such a compact fast neutron nuclear reactor, as it is the only country in the world that has experience in successful industrial operation of this type of reactor. Only Russia has industrial fast neutron reactors today. These are the BN-600 and BN-800 reactors. Brest-300 is under construction, and a decision is being made to build BN-1200M. And let's not forget that the ZEV's transport power module is also designed on the basis of a compact fast neutron nuclear reactor. This is what ZEVs should look like from the Roscosmos presentation. However, the Burevestnik has one big difference from the US SLEM project. The Burevestnik engine does not emit radioactive jets during operation. Until Putin's presentation in 2018, no one had ever known about the ongoing tests of the Burevestnik. The only short-term spike in radiation background was recorded on August 8, 2019 in the area of the Russian Navy's NENAKSA missile range in the Arkhangelsk region. According to the Russian Defense Ministry and Rosatom, the incident was caused by an explosion of a liquid rocket engine with a radioisotope power source. The media published speculation that the explosion was related to the testing of the Burevestnik missile. Given that short-lived anthropogenic radionuclides, which are fission products of uranium isotopes and transuranic elements, have been detected in the air, it can be assumed that the radioisotope power source is based on isotope fission reactions rather than decay reactions. The short duration of the release indicates that even if the Burevestnik reactor did explode, it was very compact, just the size of a radioisotope power source with a small stockpile of nuclear fuel. According to U.S. intelligence agencies, there have been at least 5. Other estimates say 8 launches of the Burevestnik between 2019 and 2021. No radioactive releases were observed before or after the Nenox incident. But then how is the jet propulsion of the storm petrel created? In Burevestnik, because of the air density, only a direct flow open-type gas turbine can be used, and the reactor core must be blown through, blowing all radioactive isotopes outward and contaminating the terrain over which the rocket flies. Actually, many people assume that it is implemented this way. For example, the U.S. President's Special Envoy for Arms Control, Marshall Billingsley, called Storm Petrel a flying Chernobyl. However, no further traces of radioactive decay, as well as traces of the products of this decay, have ever been detected, and this is simply impossible when using a core-purged layout. The Americans were closely following the Burevestnik tests, and the whole world was following these tests. But if this is true, and Russian scientists have succeeded in creating a nuclear reactor that is able to create a powerful jet with its heat, while not emitting radioactive isotopes, then this is a revolution in the field of powerful and compact nuclear engines. So the most valuable thing about this missile is not the nuclear-powered missile itself, but the technology that goes into it. It is theoretically possible to make such a reactor. Its core should be heated to a temperature of 1,600 degrees Celsius. Blowing off the external heat sink at this temperature will produce a powerful jet thrust, especially in the dense layers of the atmosphere. But there are no materials in the world that can withstand such core temperature under neutron irradiation. Is. The ZEV's transport power module reactor must also operate at these temperatures. Consequently, similar materials can be used in the Burevestnik reactor. It is highly likely that these projects overlap, especially in terms of the nuclear reactor. Completion of the Burevestnik tests shows that the technology is fully developed. The nuclear direct flow engine operates by heating the air through a cooling circuit rather than by direct blow through of the core. And it turns out that a nuclear power plant is a small core that is turned on when it reaches a speed of 500 to 800 km per hour. The core is unattended, sealed, with a limited stockpile of nuclear fuel. Suspended from the radiator grill in the center of the jet engine. There may be more than one active zone. The reactor is cooled by blowing air through the radiator grill. This prevents the reactor core from cooling as efficiently as possible, causing it to heat up to 1,600 degrees Celsius. On the photo tests Burevestnik, top left photo Burevestnik assembly shop, top right photo Burevestnik acceleration with rocket boosters. Photo of the general plan of the start of the Stormtrooper. By the way, the cruise missile was named Burevestnik according to the results of an open vote on the website of the Russian Defense Ministry. The title Surprise and Surprise also scored well. The humor here is just right. In general, new refractory materials capable of operating at 1,600 degrees Celsius are well suited to such a reactor layout. If this is true, and all indications are that it is, and scientists have created a nuclear air jet engine without radioactive exhaust, there are tremendous prospects for mankind. In the 1960s, the development of a nuclear-powered airplane that could stay in the air for weeks did not succeed precisely because of the impossibility of creating a pure nuclear-powered jet engine, although protection of the crew from radioactive background was successfully created. In our time, this problem has been returned to repeatedly. For example, in 2003, as part of the ambitious U.S. Future Combat Systems program, the U.S. Air Force Military Research Laboratory funded the development of a nuclear-powered engine for the Global Huff unmanned reconnaissance aircraft to extend the flight time to several months. However, when creating a nuclear reactor of a clean exhaust engine, the Americans faced a number of technical difficulties that they were unable to overcome. The program was shut down in 2009. It's no wonder why Western experts previously considered Storm Petrel to be a Putin cartoon, because if the US failed, the Russians shouldn't have succeeded. They said the same thing about hypersonics back then. As a result, Russia got not only the world's first clean nuclear cruise missile with an impressive range of at least 20,000 kilometers, but also the technology of a clean nuclear direct flow engine, which can now be developed and used virtually anywhere. In the production of reconnaissance drones, in the production of cargo planes or transport airships, in the production of strategic bombers, and in the civilian sphere, for example, in the creation of aerial vehicles. This is what the US is most afraid of, not just the very strike potential of the Burevestnik, which is certainly an order of magnitude higher than that of any cruise missile.